So in the last video, was discussing the constant V over F and the frequency control. And let's recall that if this is the frequency and this is the voltage, and simply we assume that we are following a constant V over F until the F rated, at which the voltage must be Vs rated, and after that we have a frequency control until we have here F max. In general, the maximum frequency is decided by the mechanical structure of the system, how much vibration the shaft can handle. So from here to here we have the frequency control, and from here to here we have the constant V over F control. Now in the constant V over F control we have Vs is equal to K Vs rated, and we have the frequency Fs equal K Fs rated. So the ratio between Vs and Fs all the time will be constant. Now in the frequency control, if the frequency exceed the rated value, then the voltage should be fixed, so Fs is equal Vs rated, while Fs is equal K Fs rated, and here K is greater or equal to 1, while in the constant V over F we have K less than 1. Now the torque speed characteristic for the constant V over F. Recall that Te will equal to 3 over S omega S mechanical RR dash Vs squared over Rs plus RR dash of S all squared plus X LS plus X LR dash squared. Now please note that those values are calculated at the rated frequency. So to counter for changing the frequency and the voltage, Te can be written as 3 over S K omega S mechanical rate. Here we have RR dash, and here we have K squared Vs rated squared over Rs plus RR dash over S plus K square XLS plus XLR dash squared. So simply now you can use the same value of the reactance, except that now we are shaping the reactance according to the frequency. And recall that K in this case is less than or equal to 1 and greater than 0. The slip at the maximum torque which is the S max, will equal RR dash over the square root of RS square plus K square XLS plus XLR dash squared. Here I'm taking only the motor action. In the same fashion, we can write the maximum torque T max, which will equal 3 over 2 K omega S mechanical rated K square PS rated square over RS plus the square root of RS square plus K square, summation of the inductance, X LS plus XLR dash squared. One of the advantage of the V over F control is that if we assume that RS is very small such that can be neglected, then T max is almost equal to 3 over 2 K square X LS plus XLR dash, and here we have K square VS rated square, which almost equal constant. And this one is almost equal to T max at rated value. So if I need to plot the torque speed characteristic in this case, under the assumption that RS is small or negligible, then if this is the N, this is the N S, this is the rated, let's say, torque speed characteristic. Now for certain frequency, let's say less than Fs, the synchronous speed will be less than the rated, and simply we have the following torque speed characteristic. Let's say almost T max is constant. And if we have, let's assume the following torque speed characteristic, now we have a wide range of speed to control. Now what about if we increase the frequency above the rated? In this case, we cannot increase the voltage. So for frequency control, which is case number 2, for frequency control, the stator voltage is fixed at the rated value, while the frequency is increased above the rated. And here K is greater than 1 or equal to 1 to include the switching point. So in this case, the torque TE will equal to 3 over S K omega S mechanical rated. Now here we have VS rated square without K, because already the stator voltage cannot exceed its rated value, over Rs plus Rr dash over S whole squared plus K squared X ls plus X lr dash squared. And this is the what we call the frequency control.